Hello all. Today I am talking about pavement. That is, what is pavement? Pavement is a structure consisting of superimposed layers of processed materials above the natural soil subgrade, whose primary function is to distribute the applied vehicle load to the subgrade. And a pavement should able to provide a surface of acceptable riding quality, adequate skid resistance, favorable light reflecting characteristics, and low noise pollution. The aim of a pavement is to ensure that the transmitted stresses due to wheel load are sufficiently reduced so that they will not exceed bearing capacity of the subgrade. And these are the basic requirements of a pavement. That is, an ideal pavement should meet the following requirements. First of all, a pavement should have sufficient thickness to distribute the wheel load stresses to a safe value on the subgrade soil, and a pavement should structurally strong to withstand all types of stresses imposed upon it. Then the pavement should have adequate coefficient of friction to prevent skidding of vehicles. Then it should have smooth surface to provide comfort to road users even at high speed, and it produces least noise from moving vehicles, and its surfaces must be dust proof so that traffic safety is not impaired by reducing visibility. Then the surfaces should be impervious because so that subgrade soil is well protected, and it should have long design life with a low maintenance cost. Then moving to types of payments, mainly three types of payments are there: flexible payments, rigid payments, and composite payments. First of all, flexible payments. Here, wheel loads are transferred by grain to grain contact of the aggregate through the granular structure. These payments have less flexural strength and acts like a flexible sheet. Example, bituminous road. Here, the load transmit wheel load stresses to the lower layers by grain to grain transfer through the points of contact in the granular structure. The wheel load acting on the pavement will be distributed to a wider area, and the stresses decreases with depth. Design of a flexible pavement uses the concept of layered system. Design is based on overall performance of flexible pavement, and the stresses produced should be kept well below the allowable stresses of each pavement layer. This is the figure of load transfer in a granular structure. Then this show a typical cross section of the flexible pavement. That is, typical layers of a conventional flexible pavements includes natural subgrade, above which compacted subgrade, and above which subbase goes, then base goes, binder goes, and surface goes. These are the typical cross section. These are the typical layers of a conventional flexible pavement. Then rigid pavement. Rigid pavement, in this type of pavements, wheel loads are transferred to subgrade soil by flexural strength of the pavement, and the pavement acts like a rigid plate. Example, cement to concrete road. It has sufficient flexural strength to transmit the wheel load stresses to a wider area below. Compared to flexible pavement, rigid pavements are placed either directly on the prepared subgrade or on a single layer of granular stabilized material. Since there is only one layer of material between the concrete and the subgrade, this layer can be called as base or subbase course. Here, load is distributed by the slab action, and the pavement behaves like an elastic plate resting on a viscous medium. Then this is the typical cross section of a rigid pavement, that is base or subbase course, and above which a Portland cement to concrete. So it is the typical cross section of a rigid pavement. Then third type of pavement is composite pavement. It is a thin layer of flexible pavement over rigid pavement is an ideal pavement with the most desirable characteristics. Rarely used in new construction because of high cost and complex analysis required. Then what are the difference between flexible pavement and rigid pavement? That is, most commonly used pavements are flexible and rigid. So here these are the difference between flexible pavements and rigid pavement. In flexible pavements, there is grain to grain load transfer, and initial cost is low, joints are not required, durability is less, good subgrade is required, temperature variation has no any effect on the stress variation, lifespan is short, that is about 15 years, repair work is easy, maintenance cost is high, requires less curing time, poor night visibility due to use of bitumen, no glare due to sunlight, easy to locate the underground works like pipe location, etc. Thickness is more, design depends upon the subgrade strength, stability depends upon the aggregate interlocking particle friction and cohesion, and design is based on IRC 37. Then rigid pavements. In rigid pavements, slab action takes place. Initial cost is high, joints are required, durability is high, good subgrade is not required, temperature variation affects the stress variation, long lifespan, that is about 30 years, repair work is tough, maintenance cost is low, requires much curing time, good night visibility, high glare due to sunlight, difficult to do the underground works, thickness is less, design not depends on subgrade, stability depends upon the joints between the slabs of concrete, and design is based on IRC 58. So these are all about the basic details of pavements. Thank you.